Moving on in chapter 17. Next, we're going to talk about the units that we have for all of our energy this chapter. So the first one is a calorie, which you probably have heard of calories before, but this is not the food calorie, okay? A calorie is the amount of energy or heat required to raise the temperature of 1 gram of water by 1 degree Celsius. So lowercase c. Food calories are represented by the capital C in science, and they're actually 1 kilocalorie, which you might need to know this. 1 kilocalorie is equal to 1,000 calories. Okay, so if you have kilocalories and you need to get calories, use 1,000. Okay, just like milliliters and liters, or move your decimal places 3 times. That works too. A joule is actually the SI unit of the energy, and 1 small calorie, so 1 small C calorie, is equal to 4.184 joules. And that 4.184 is important. We're going to use that a lot. Okay? So if we knew all this information, we could figure out how many joules of energy would a 100 calorie snack have. So let's go ahead and do that. You have a little bit of space down there. So if we know that we have a 100 calorie snack, and that's a big C calorie, we're going to put that over 1. We're doing dimensional analysis, by the way. So we start with what we know over 1. Now, it says above that 1 big C calorie is equal to 1 kilocalorie. So that could be our next part in the equation. So that cancels out our big C calories. Next, there are 1,000 small calories and 1 kilocalorie. So we got to get rid of those kilocalories. And then last but not least, we know that there are 4.184 joules for every 1 small C calorie. So that's our last step, because we're trying to find joules. So to find our answer, you're going to take 100 times 1,000 times 4.184, and you should get 418,400 joules, which is a pretty big number. So we could put that in scientific notation, or we could change that even to kilojoules. But there we go. That's our answer. So what do we do with all this stuff? We actually have what's called a specific heat capacity. The specific heat capacity is the amount of heat needed to increase the temperature of an object, any object, exactly 1 degree Celsius, and we call that heat capacity, okay? The difference between heat capacity and specific heat capacity has to do with the mass of the object, okay? It's dependent upon the mass of the object, and it's dependent on the chemical composition of that. So, when we're talking about the mass side of things, we use specific heat capacity, which is, we're going to do all of our calculations with the specific heat capacity, okay? So the definition of a specific heat capacity is a substance that the amount of heat that it takes to raise a substance, 1 gram of that substance, 1 degree Celsius. So the unit for specific heat capacity is joules per grams degree Celsius, as you see right there. Or another way to write it, joules over grams degrees Celsius. And that's going to be important in our calculations for the day. So you have this table in your note packet. It's a list of very common specific heat capacities. I would keep this handy because you might need it when doing your homework assignment or other things like that. So, but if you notice, not only is it divided up by substance, but even water, all three states of matter for water have their own specific heat capacity. So not only is the substance, but also the state of matter important. So like, if you look over here, liquid water has the 4.184 that we mentioned before. Solid water, so this would be ice, has 2.03. And gaseous water has 2.0 exactly. So it all depends on what it is. But the specific heat capacity, they stay set in stone. When a substance has a higher specific heat, so it means that number is bigger, that means that it takes more energy to heat or cool that substance than if something has a lower specific heat capacity. Okay? So, thinking about that, which substance, aluminum or liquid water, would heat faster? So, you could even think about this like when you are cooking like when you're trying to boil water. What's going to heat up first? Well, aluminum has a specific heat of 0.89 joules per gram degree Celsius, and liquid water has 4.184 joules per gram degree Celsius. Well, aluminum has a lot smaller number, so that means that it will heat up faster. So the answer would be aluminum. Another way to think about it, just use your common sense. When you are trying to boil water on the stove, does the pan or the water inside the pan heat up first? The pan does, right? So that means that the pan, the metal will have a lower specific heat than water, because water needs more energy to actually heat up. All right, so the energy equation. Q, remember, is our heat that we talked about before. And Q is going to be in joules for this set of calculations, and that stands for the energy or the heat. Okay. M is the mass, and mass is going to be in grams. The specific heat capacity is the C. So you might have to look it up in the table, or I might give it to you in the problem, or you might even have to solve for it. And that is joules over grams degrees Celsius. And then last but not least, we have T stands for temperature in degrees Celsius. Okay? And that little delta sign in front of the T stands for temperature change, the change in temperature. So we're not going to need just one number here. We're going to need the difference of two numbers. Okay? So to find the change in temperature, that's all one big thing. Find that. You take the final temperature minus the initial temperature. So T final minus T initial. So where it ends up is minus where it starts with. Okay? We can plug and chug. I call this equation the MCAT equation because it kind of looks like MCAT. If anybody's trying to think about being a doctor, you have to take the MCAT to get into medical school. So you have to have a good score on the MCAT test. And so I call this the MCAT equation because that's what it looks like. All right, let's go ahead and solve it out. So example 2. How much energy in joules is required to heat a piece of iron weighing 1.3 grams from 25 degrees Celsius to 46 degrees Celsius? Well, we're using our MCAT equation. So Q equals MC delta T. And let's label everything to know what we have and know what we're trying to solve for. So if we're solving for energy, because it says how much energy, that is going to be our Q in the equation. And we know we have iron. That's important. Iron is important. It's not anything else. It's iron. And the weight of the iron is 1.3 grams. So that's our mass. And it starts at 25 degrees Celsius. So from 25 to 46. So that means 25 degrees Celsius is our initial temperature and 46 is our final temperature. Okay, so we got all of our information from the problem. Let's go ahead and start plugging in. We want to find Q. So Q equals, we know the mass is 1.3 grams. Next up we have C. So with the C, you know that handy dandy little table on page 4? If you flip back over there and look down there, you can see that iron has a specific heat capacity of 0.45 joules per gram degree Celsius. That's what we're going to plug in for the C, because that's the specific heat capacity of iron. So the identity of the substance is important here. And then last but not least, we need to take the change in temperature. So if you would like to solve for the change in temperature first before plugging it in, you can. Or you plug it in and then solve for that first. So you're going to take 46 minus 25 for your change in temperature. So when we subtract those two, I'm going to omit the units. When you take 46 minus 25, you should get 21 degrees Celsius. So our change in temperature is 21. So now we can solve. Take 21 times 0.45 times 1.3, and you should get around 12.29 as your answer. Our unit is joules because it's energy or heat that we're talking about. So we're going to put joules on there, and then we have to round to sig figs. There are 2 sig figs in each number in the problem, so that means that we round to 2, so that is going to be simply 12 joules. 12 joules for our final answer. So this would be like solving for Q, the easy of the two that we have for examples today. Example 3 gives us Q, and we have to solve for something else. So let's go ahead and do that. Example 3. A 1.6 gram sample of a metal that has the appearance of gold requires 5.8 joules of energy to change its temperature from 23 degrees Celsius to 41 degrees Celsius. Is the metal pure gold? We're using our MCAT equation again. So let's go ahead and label what we know. A 1.6 gram sample. So that means our mass is 1.6 grams of a metal that has the appearance of gold. That's important, but not yet. Requires 8.5 joules, so that's joules, that's going to be our Q of energy, to change its temperature from 23.1 to 23, from 23 to 41. So that's final. Is the metal pure gold? Well, looking at all of our numbers that we're given, we are given a Q, we're given an M, we're given temperatures to figure out the difference. We are not given C. In this problem, we are going to solve the energy equation for C and then compare it to the specific heat capacity of gold, which is in our table on page 4 of our notes. And if it's the same number, then we can say yes, it is pure gold. But if it's not the same number, then we're going to have to say, nope, it's not. Okay? So, we're going to take 5.8 joules equals 1.6 grams times C, we're solving for C here, times T final minus T initial. So to simplify this out, we're going to take 5.8 equals 1.6 times C times, when you subtract 41 minus 23, you should get for your temperature difference 18 degrees Celsius. So then, to solve this, if we would first multiply on the right side, 1.6 times 18, you get 28.8 times C equals 5.8. So to get C by itself, we're going to divide both sides by 28.8. So then C equals 0.201 joules per gram degrees Celsius. Okay, so we've solved for C, but that does not solve our full problem because it asks us, is the metal pure gold? Well, now we look on page 4. Look over in the table on page 4. So flip over your notes. And when you look down, it's near the bottom. Gold has a specific heat capacity of 0.13. Is that what we have? No. So that means that no, we don't have pure gold. So that answers the full entire question that we have. That's it for today. So we're going to stop now, and you can now do numbers 3 through 7 on the homework packet. Take the time in the class to get it done. Ask me any questions you have. Have your notes and the table of specific heat capacities handy when you do this. All right, talk to you later.